Hi everyone, my name is Bharti. Let's see today's topic circles chapter from 9th standard CBSE. So, what is the definition of a circle? A circle is a collection of all those points in a plane which are at a constant distance from a fixed point in the plane. So, here a circle is a collection of all points in a plane. Yes, all those points in a plane which are at a constant distance. Which are at a constant distance from a fixed point. What is that fixed point here? O. Okay, that we will call as the center of the circle. Then here OA is nothing but radius of the circle. Now we can draw one more joining from O to B also. Even O to B is nothing but the radius of the circle. O to C, if I join, it is the radius of the circle. So from fixed point to any point on the circle, if we join, that will be called as the radius of the circle. Now let's go on to the next definition. Chord, a line segment joining any 2 points on a circle. Okay, so here what is the line segment here? AB is the line segment. The line segments joining any 2 points on a circle. So A and B are the 2 points if I assume. So those 2 points if we join on a circle will call as a chord of a circle. Even if I join from C to D, even this C to D is called what? Chord of a circle. If join any 2 points on a circle, it is called the chord of a circle. Next one, diameter. What is the diameter? It is also one of the chord. Okay, but a chord is passing through the center of a circle. So joining any 2 points on the circle, what we are telling, it is the chord of a circle. But here it is passing through the center. A chord passing through the center of a circle. Now this is the chord. It is passing through the center of a circle. It is called what? Diameter of a circle. Now if I join from here C to D. Yes, even CD is what? Chord of a circle. But it is passing through center of a circle. It is O. So we can call CD as the diameter of the circle. Even AB as the diameter of the circle. So by this, how many diameters we can draw? Infinite diameters we can draw here. Yes. Now as we know, so OA is equal to R and OB is equal to R here. So OA is equal to R, OB is equal to R here. What is AB length? It is the diameter. How we will get? By joining the OA plus OB. OA plus OB, it is OA is what? R and OB is what? R. OA plus OB is nothing but 2R. That means diameter AB is equal to the 2 times the radius. So let's see the important question here in the circle. Equal chords of a congruent circles. Equal chords of a congruent circles subtend equal angles at their centers. Yes. So equal chords of 2 congruent circles. 2 congruent circles means what? You will be having with the same radii. Now I am considering with the 2 circles with the same radii. Correct? That means OA, OB length are equal as well as O dash C, O dash D radius also will be equal. Equal chords of congruent circle. Subtend equal angles at the center. What are the angles here at the center? Means here AOB angle and CO dash D angles are equal, we have to prove. That is our required to prove. As they are given. So equal chords. What are the equal chords here? Joining any 2 points on a circle, right? Yes. So AB and CD are 2 equal chords of the given given triangles. What? OAB triangle, O dash CD triangles here. Now we need to prove AOB is equal to CO dash D, equal angles at the centers. What are the centers here? O is the center of the circle for the first circle and O dash is the center for the second circle here. Now to prove angles are equal, let's prove these 2 triangles are congruent. So what are those triangles? Triangle AOB and triangle CO dash D here. So as we know here OAB is equal to CD. As they are given equal chords, right? Yes. AB is equal to CD. It is given and OA will be equal to what? O dash C. OA will be equal to O dash C because those are congruent circles. It is also given radii. It is given in the sense it is to a radii. And OB is equal to what? O dash D because those are congruent circles. OB is equal to O dash D. Even this is radii. These both are equal. Now triangle AOB is congruent to triangle CO dash T because by using the SSS congruency rule. Correct? Now OA is equal to O dash C, OB is equal to O dash D and AB is equal to CD. We got it actually. Now so by this it is following with what? SSS congruency rule. Then as from the CPCT, what we can write? AOB is equal to CO dash D by CPCT. Correct? Our required to prove what? Equal angles at the centers. Now, AOB is equal to CO dash D. So, therefore, here our required to prove AOB is equal to CO dash D we got. Hence, proved. Okay. Let's see one more question here. If chords of congruent circles, subtend equal angles at their centers, then chords are equal. So, our required to prove. So, here they are given two circles are congruent circles as well as here subtend equal angles at their center. That means AOB is equal to CO dash D. Equal or not? Yes. Next, we require to prove then the chords are equal. That means we need to prove AB is equal to CD are equal. So, as from the given data, AB and CD are two chords respectively such that AOB is equal to CO dash D. They are given. Correct? Now, here to prove the angles, then to prove the chords are equal, let's show these two triangles are congruent. What are those triangles actually? Triangle AOB and triangle CO dash D here. So, as we know, OA is equal to O dash C. Why? Because those are radii. Congruent circle, right? Radii is equal. And AOB is equal to CO dash D because they are given subtend equal angles at their center. So, angle AOB is equal to angle CO dash D. Correct? It is from the given data. And already we know that OB is equal to O dash D because that is also radii, right? Yes. OB is equal to O dash D. This is also radii. Correct? Now, so what I can say here? This OA is equal to O dash C and OB is equal to O dash D. So, these two triangles are following with which criterion? Side, angle, side. Correct? So, by SAS congruency criterion. So, triangle AOB is congruent to triangle CO dash D here. By which criterion? SAS congruency criterion. So, from CPCT what I can write? AB length will be equal to CD length, right? Yes. AB is equal to CD. That means the chord length AB will be equal to the chord length CD are equal to each other. That is our required to prove. So, this is proof. Let's see one more important question. If a line intersects two concentric circles with center O. If a line, what is that line here? L is the line, intersects two concentric circles. What is the meaning of concentric circles? It will be having with the same center. Okay. At center O, at ABCD, prove that AB length will be equal to the CD length. That is our required to prove. So, as we written here, what is our required to prove? AB is equal to CD. Now, I am going to do the construction OP. Join from O to P here. This OP will be perpendicular to L. What is that? OP is perpendicular to L here. We know that. So what we know here, the perpendicular from the perpendicular from the center of a perpendicular from the center of a circle to a chord bisects the chord. So here what they are telling, the perpendicular from the center of a circle bisects the chord. So can I consider BC is the chord for the smaller circle? Yes or no? So BC is the chord for the smaller circle means it bisects the chord, meaning the length of BP will be equal to what? CP length. So we know that BP is equal to what? CP. Let's give this as equation number 1. In the same way, AD will be the chord for the bigger circle. Correct? AD is the chord for the bigger circle means perpendicular. That means AP will be equal to PD or not here? Yes, bisects the chord. So we can write AP is equal to, we can write as DP. This is equation number 2 here. So I am going to do, I need AB length as well as CD length. How I will get from AP, if we subtract BP, let me get as AB, right? Yes or no? So from PD, if we subtract PC, we'll get CD. So that from equation number 2 minus equation number 1 I am doing. So AP minus BP. In the same way, DP minus CP. So AP minus BP, it is nothing but what from the figure? AB I can write. So and again DP minus CP is nothing but what here? CD. So our required to prove what? AB is equal to CD here. Okay. So first of all we should know this point very clearly. We know that perpendicular from the center of a circle. Perpendicular. Yes. Perpendicular from the center of a circle to a chord. Bisects the chord. Yes or no? So BP will be equal to CP and AP will be equal to DP. So this bisects the chord, we should understand. That is our required to prove what we need. AB is equal to CD. Let's see one more important question here. Two circles of radii 5 centimeters and 3 centimeters intersect at 2 points and the distance between their centers is 4 centimeters. Find the length of the common chord here. Yes, two circles. What are the two circles I have taken? This is the one circle with the radius is how much? It is 5 centimeters. So that can I say C1P as the radius? Yes. So C1P is 5 centimeters. It is the radius of the bigger circle and 3 centimeters. One more circle is what? 3 centimeters having with the radius. So this is one more circle having with the radius is what? C2P. It is what? Radius. So because C1 is the center of the bigger circle and C2 is the center of the smaller circle. Because we have drawn intersecting, because they are given those two intersects at 2 points and the distance between their centers. So those two circles intersects at 2 points. Yes or no? So what is that point it was intersected? Those two circles intersected at P and Q. And the distance between their centers. What are the distances here? C1. C1 is the center of the bigger circle and C2 is the center of the smaller circle. Distance between their center. That means C1 to C2 is how much is the distance? 4 centimeters. Radius of the bigger circle is what? C1P. It is 5 centimeters and C2P. It is the radius of the smaller circle. It is 3 centimeters. As from the given data, let's write C1P is equal to 5 centimeters and C1 C2 is equal to 4 centimeters and C2P is equal to what? 3 centimeters here. So from this what I can write? Let's write 5 square is equal to 3 square plus 4 square. Correct or not? 25 is equal to 9 plus 16. 25 is equal to 25 we got. That means as we got 25 is equal to 25 means here. So can I say this is a Pythagorean triplet? Yes or no? Correct. So that means these 3, 4, 5 it forms a Pythagorean triplet. That means C1, C2P, this triangle C1, C2P triangle is what? Right angle triangle here. Correct. So from this what I can write? C1P square is equal to C2P square plus C1 C2 whole square. So where I can write the right angle here? C1 angle C1 C2P is equal to what? 90 degrees. So we understood this is the right angle triangle. So from this what I can write here? C2 lies on a common chord PQ. Correct? C2 lies on a common chord PQ and it bisects PQ. And it bisects PQ. Correct or not? From center to the chord, if you draw the perpendicular, it bisects the chord or not, as we learned before here. So that means, can I say C2 is the midpoint of PQ? Yes, C2 is the midpoint of PQ. Correct? So here the line segment joining the line segment joining the centers of two circles bisects the chord. Because PQ is the common chord, right? Yes. So from perpendicular if we draw means it bisects the chord. That means PQ can I write as 2 times of C2P. Correct or not? So 2 times of C2P. 2 into what is the C2P length from the given data? 3. Correct? 2 3s are 6. So what is the length of the common chord? PQ is equal to what? 6 centimeters. Find the length of the common chord. What is the common chord here? PQ is the common chord for the both the circle. That length is how much it is? 6 centimeters. Let's see one more important question. If two chords of a circle intersect within the circle. So this is the circle, correct? Now what are the two chords here? AB and CD are two chords. Those two chords intersect within a circle. Those two chords intersect at what point? O point. And what is the center for the circle here? O is the center of a circle. If two chords of a circle intersect within the circle, then prove that the segment of the one chord are equal to the corresponding segment of the other chord. Segment of one chord. So AP is the segment for CD. Yes or no? Next, in the same way, CP is the segment for AB chord. So those two segments are equal, we have to prove. That means AP is equal to CP. In the same way, BP is equal to DP, we have to prove. Because DP also is the segment and BP also segment for the corresponding chords, right? Yes. Now, next one more question. The line joining the point of intersection to the center. The line joining the point of intersection. What is the point of intersection here? O is the point of intersection. So makes equal angles with the chord. So that means we have to prove OPL angle will be equal to OPM angle. So how can we prove these two angles are equal? Yes, we can prove by taking these two triangles are congruent. So let's consider OPL triangle and OPM triangle here. So as we know, we have done the construction. What is our construction here? OL will be perpendicular to AB and OM is perpendicular to CD. Correct? As we know, center to the chord, if we draw the perpendicular, it bisects the chord. One more, that point we know. And here, to show these two triangles are congruent, OL is equal to OM we can write. Yes. Next one, OP is the common side. Next, OLP is equal to OMP we can write. Correct? So, let's draw. We have drawn the construction. OL is perpendicular to AB and next one OM is perpendicular to CD. Let's go to the solution. How to write here? We are going to show with the two triangles are congruent. What are those triangles here? OLP, OLP and triangle OMP. Let's go in the order way. So OLP we have taken. So let's go with the order. OMP triangle here. So as I said, OP is the common side, right? Yes. OP is equal to OP. It is common. Next one, OLP is equal to OMP, right? Yes. OLP is equal to OMP. We have taken, that is 90 degrees perpendicular through our construction. Correct? Next one, we can write OL is equal to OM. Correct or not? OL is equal to OM. By which point? Equal chords are equidistant from the center. Correct? Equidistance from the center. So OL is equal to OM we got. So now these two triangles, that means OLP triangle is congruent to which one? Triangle OMP. By which criterion here? See, OP is the common side and these two are equal. So right angle hypotenuse side. So by RHS congruency criterion. So after getting the RHS congruency criterion, can I write those two angles are equal? OPL is equal to OPM. Check the here. P will be equal to P here. Correct? OPL is equal to OPM by CPCT. In the same way, can I write LP will be equal to MP? Yes or no? Yes. We can write LP is equal to MP. Let's give this as equation number 1. Correct? So, our required to prove angle side equal here. We have to prove OPL is equal to OPM. We got it. Next. Okay. So, we have got the OPL is equal to OPM by showing the congruency. Next, what is our required to prove? AP is equal to CP as well as BP is equal to DP. So, we got here the conclusion with the CPCT is what? LP is equal to MP. I have given with the equation number 1 here. Next, from the given data, as I got AB is equal to CD. Those two are equal chords, right? Yes or no? Yes. Now, I am going to multiply half on both sides. Half of AB is equal to half of CD. Half of AB, can I write AL? Yes. AL is equal to half of CD. Correct or not? Half of CD is nothing but what? CM. Correct? So, perpendicular from the center, it bisects the chord, right? Yes or no? So, that's why CM is equal to MD we can write. Correct? So, half of AB is AL, half of CD is what? CM we got. So, as we know, AL, I am going to add LP on both sides. LP. AL plus LP is equal to CM plus LP. Because equals I can add on both sides. Correct. Now, AL plus LP is equal to CM plus LP is nothing but can I substitute with MP? Correct? Yes. So, it is from equation number 1 here. Now, AL plus LP. AL plus LP is what? AP. And CM plus MP is nothing but what? CP. Correct? We have got it. Now let's give this as equation number 2. Our required to prove AP is equal to CP we got. Next, one more what we have? BP is equal to DP. Correct? Now to prove that one, from chord AB, AB minus AP means BP will get. Correct? In the same way, CD minus CP means CD will get. Correct? Now, we know that AB is equal to CD, right? From AB, I am going to subtract AP because these two are equal. CD minus CP, equal cards. AB is equal to CD and these two are equals. Minus AP minus CP. Then we will get BP is equal to DP. So, this is our required to prove. Go. Let's see one more important question here. So, a circular park of radius. A circular park. Okay. So, this is a circular park of radius is 20 meters. So, G is the center of the circle. So, AG length will be equal to what? AG is equal to 20 centimeters and BG also it is what? 20 centimeters as it is the center of the circle. It is the radius. And next one here is circular park of radius 20 meters is situated in a colony. Three boys, Ankur, Syed and David. So Ankur, Syed and David. Okay, A I given as Ankur and B is what? Syed, C as David. Three boys, Ankur, Syed and David are sitting at equal distance on its boundary. Correct? So, it's a boundary means what? Circular. Correct? Now, it's equal distance. That means AB equal to BC is equal to AC. Equal distance on its boundary. Each having a toy telephone. Each is having toy telephone in his hand to talk each other. Find the length of the string of each phone. Yes or no? So they are equally distance. So AB is equal to BC is equal to AC. As G is the center of the circle, AG will be equal to BG is equal to CG. It is the radii with 20 centimeters. The length of the string. To talk each other, they are using telephonic toys. So that the length of each string is how much? I need to find out. So AB length, BC length and AC length. So now as we know they are equally placed. That means all the distances are equal to each other. Once if you find any one length, all are equal to each other. So from the given data we have got this one. So easily I will explain here how to do here. I am joining from A to D, B to E and C to F here. That is our construction. Now I am going to take with the triangle ADB. Correct? This is an equilateral triangle means from vertex to opposite side. If we draw a line segments, it bisects the chord as well as it is a perpendicular. As it is an equilateral triangle, can I consider this as the length A and this is A and this is also A. AB is equal to BC is equal to AC. Now it bisects the chord means can I consider this is A by 2 and CD is what? CD is also A by 2. Let's write BD is equal to what? A by 2 centimeters. And next one, I am going to construct a triangle ABD. Correct? ABD triangle. As it is a right angle triangle, I can write AB square. That means right angle opposite side is what? Hypotenuse. AB square is equal to BD square plus AD square here. What is the AB length? It is A, right? Yes. A square is equal to, what is the BD length? A by 2. A by 2 whole square and AD length we don't know. Let's write it is AD square. Now A square is equal to A square by 4 plus AD square. So from this what I can get? AD square is equal to A square minus A square by 4, right? Correct. Now AD square is equal to 4A square minus 3a square by 4 here. Now, so it is nothing but 3a square by 4. Now, AD square is equal to 3a square by 4. That means AD length is what? Square root of 3a square by 4. So, here a into root 3 by square root of 4 is what? 2. So, AD length we have got with what? A into root 3 by 2. Now, if I need GD length means how can I find out? GD length is nothing but AD minus AG, right? Yes. So as we got the value AD length, what is the AD length here? Root 3 by 2 A we got. Now, if I need GD length, so GD length, if you want to get, can I subtract AD minus AG? Correct? AD minus AG we have to do. What is AD length? Actually we got it. AD length it is root 3 by 2 A. So from 1 we can tell, and AG is the radius of the circle from the given data. So radius is how much here? 20. So root 3 by 2 A minus 20. So we have got this value from equation 1 here. Now I am going to do with the triangle, taking with the triangle BDG. I am taking with the triangle is what? Triangle BDG. So this is also right angle triangle. I can write BG square is equal to BD square plus GD square. Correct? Now BG value, as it is the radius of the circle, I can write it is what? 20 square, and BD length is how much? A by 2 whole square, and GD length we have got from here, that is root 3 by 2 A minus 20 whole square. Correct? Now 20 square is nothing but what? 400. A square by 4. I can apply A minus B whole square. What is A minus B whole square? A square plus B square minus 2AB. So from this, root 3 by 2 A whole square plus 20 square minus 2 into root 3 by 2 A into 20 we can write. Now 400 is equal to A square by 4 root 3. That means square root cancel. We can write 3A square by 2 square is what? 4. 20 square is nothing but what? 400. Let's cancel 2 and 2. It's nothing but 20 root 3A. Yes. Now 400 by transposing this side, it becomes what? Minus 400. Now let's ask these two. Now A square by 4 plus 3A square by 4 is what? 4A square by 4 minus 20 root 3 A here. 0 is equal to 4 cancel. A square minus 20 root 3A. So let's take the value this side. 20 root 3A is equal to A square. By cancel 1A, it becomes A is equal to what? 20 root 3. So A is nothing but what? AB, BC and AC. That means length of each string. AB is equal to A, that is equal to 20 root 3. So AB is equal to BC is equal to AC. Those are equal length. So our required to prove what? Length of each string. Length of each string is what? 20 root 3 meters.